Well, here we go again. I'm glad to have you back, and let us jump into Unit 5, which is naming. And one of the places that I want to start here is naming polyatomic ions. Okay, so let us consider SO4 2 minus. Is this a polyatomic ion? Well, we need to take some notes, right? So let's start up here with, we've got ions, right? So what are ions? Ions are atoms with a charge. Yeah, we remember that. And if it has, well, how do you get a charge? You either gain or lose electrons. If you lose an electron, then you have a negative charge. And if you lose an electron, you have a positive charge. And if you gain an electron, you have a negative charge, right? So and what is it that we call a positively charged ion? We call that a cation. And we call a negatively charged ion an anion, right? Now, we have types of ions beyond this, and we have things that are monatomic ions, and we have polyatomic ions. Now, monatomic, what do you think monatomic is? Mon comes from what? Mono. Mono means what? One. So these are ions formed from one atom. So something like K plus, that's monatomic, or Cl minus, that's monatomic. And then we have polyatomic ions, which are going to be what? Ions formed from more than one atom. And polyatomic ions are things like SO4 2 minus. Now, what does that mean? That means I have an SO4 that is covalently bonded, and the whole thing has two extra electrons. And so we'd have something, now this is not the exact way to draw this, but if we follow the rules of Lewis structures, this is the way we would draw sulfate. And so what does that mean? That means I have covalent bonds between my sulfur and my oxygens, and then I've had to add two electrons somewhere. Maybe it's these two, or maybe it's these two, but two electrons came in from somewhere other than from the oxygens and the sulfurs. So that's what that means. And other examples, things like NH4, HCO3 minus, right? I can have three elements if I want to. C2O4, 2 minus. I can have something like Cn minus. These are all polyatomic ions. Good. So back to our first question. Is this a polyatomic ion? What do I look for first? Well, I have a charge, so that means it's an ion. I have more than one atom, so yes, this is a polyatomic ion. Next, consider SO4 2 minus, the sulfate ion. What is the formula for sulfite? Okay, so they tell me that SO4 2 minus is sulfate, and now we want to know what sulfite, and it's not the same thing. They're spelled differently. It's not a misprint. That means this is something different. So we need some more notes. Here we go. So let's take our polyatomics, and off polyatomic, I'm going to come down here, and we're going to talk about naming polyatomics. Naming polyatomic ions. Okay, I've got bad news for you here. Naming, how do we name it? Well, there's only one really good way. You must memorize. You just have to memorize them. There's a list. We'll go through, in this lecture, I'll tell you all the ones I want you to memorize, but unfortunately, you have to memorize. That's the bad news. Now, the good news is there are some tips. There are some tips that will help you, okay? And let's go through some of these tips. Let's talk about 8 versus 8. Okay, 8 and 9 have to do with the number, they relate to the number, let's say, relate to number of oxygens in ion. And what it means is 8 is usually, for our purposes, it's going to be always, 8 is one more oxygen than ite. Okay, so that's the tip. 8 is one more than ite. So we go back to our question. I have sulfate. SO4 2 minus is sulfate. So the question is, what is sulfite? Phyte, if ite versus 8, 8 is one more than ite. So how many oxygens does ite have? Well, I have O4 here. One more, that means this must be O3. And the cool thing is when I go from sulfate to sulfite, everything else stays the same. It is still a 2 minus. It is still sulfur. So sulfite is SO3 2 minus. Cool. So if you memorize sulfate, so everybody memorize sulfate SO4 2 minus, you automatically know that sulfite is SO3 2 minus. Good. Next. All right, this is for you to do. We have phosphate, chlorite, and nitrate. You guys give it a shot. Pause me and bring me back when you have an answer. Okay, 8 means what? One more than ite. So if PO4 3 minus is phosphate, then what is phosphite? Phosphite. Well, ite is one less, so PO3 3 minus. Chlorite. So we have chlorite, ClO2 minus. So that's chlorite. Then what is chlorate? Chlorate is one more than chlorite, so ClO3 minus, one more oxygen, right? And then nitrate, I have nitrate, NO3 minus. NO3 minus is nitrate. So what is nitrite? Well, NO2 minus. Good. Now notice here, this is very important. The 8 and I do not tell me an absolute number of oxygens. No, that doesn't tell me an absolute. 8 does not mean 4, because here, notice, 8 means what? 4 oxygens for phosphorus, but what about chlorate and chlorate? It's only 3. So the 8 does not tell us the number of oxygen. It only tells us a relative number, that it is one more than ite, or that ite is one less than 8. So you still have to memorize phosphate, and you still have to memorize chlorite or chlorate, one of those. And you still have to memorize nitrate. If you memorize, we'll skip this one. If you memorize this, this, and this, then you automatically get that, and that for free. Good. Okay, so now we're getting a list of everything we need to know, right? So far, you need to memorize all of these. Next. Consider carbonate and hydrogen carbonate. Okay, let's go back to our list of tips. Tips. Hydrogen. When you see hydrogen in name, that means you're doing what? That means you are adding a proton. Right? And what is a proton? A proton is an H plus. So when I add an H plus, what's going to happen to my charge? By adding the H plus, my charge will move in the positive direction. So the charge becomes less negative or more positive. I think you'll see what I mean here in a second. All right, here we go. We have carbonate and hydrogen carbonate. Now, carbonate you will memorize is CO3 2 minus. Now, hydrogen carbonate means what? That means I'm going to add a hydrogen, so it becomes HCO3. Now, when I add a hydrogen, really I'm adding a proton, which is an H plus. So what happens to this negative 2? Well, I'm adding a plus, so that negative 2 becomes what? A negative 1. Good. So this is carbonate, and this is hydrogen carbonate. All I've done is I've added a hydrogen, and the charge has become more positive by each hydrogen that I add. Got it. Now I could add another hydrogen, and it would be H2CO3. And what's the charge? Well, now the charge would be nothing, and this is no longer a polyatomic. This is what we call an acid, right? Good. Moving on. Okay, you guys do hydrogen sulfate, hydrogen phosphate, and dihydrogen phosphate. As you recall, sulfate is what? SO4 minus. And what's phosphate? Phosphate by itself is PO4 minus. Okay, pause me, and when you're done, bring me back. Okay, good. Oops, sorry. Okay, good. Here we go. Hydrogen sulfate. Hydrogen means I'm going to add an H, a proton, and if I add a proton, that's a positive charge, so it becomes HSO4 minus. Hydrogen phosphate, I'm going to add a hydrogen, HPO4, and it goes from 3 minus to 2 minus. Dihydrogen. What does di mean? Di means 2. So if it's dihydrogen, what am I going to do? I'm going to add 2 protons. So when I add 2 protons to phosphate, PO4, and then 2 protons, and that means I'm going to add 2 positives, so 2 positives and 3 minus yields just a minus. Good. So we have hydrogen sulfate, hydrogen phosphate, and dihydrogen phosphate. All right. Perfecto. Going farther. Going further. I have to remember that. Phosphate. Consider phosphate. What is the formula for arsenate? Okay, one other tip here. Here we go. Tip number 3, use the P table. Now I'll tell you, the P table doesn't always work, but it does in a few circumstances. For instance, arsenic is in the same group as phosphate. So if phosphate forms PO4 3 minus, that's phosphate. What do we think would happen if I wanted arsenate? Remember, if they're in the same group, we expect them to react the same way. So I would expect that if these guys are in the same group, that my arsenic can come in here and act the same way as my phosphorus, and I would have ASO4 3 minus. And that is exactly what happens. Now, it doesn't always work that way because nitrogen is in that group too, and it doesn't act like phosphorus and arsenic. But arsenic and phosphorus work fine that way. You could usually substitute chlorine and bromine and iodine all together in the same way. Okay? So let's go back to our question. Phosphate, we said, is PO4 3 minus. Arsenic and phosphorus are in the same group, same family in the periodic table, so we'd expect them to react the same, and there we go. All right, here you guys go. Chlorate. What is the formula for bromate, right? Chlorate is ClO3 minus. Remember, bromine and chlorine are in the same group, so I'll give you 5 seconds to get the answer. There we go. Hey, I should be able to do what? Simply substitute bromine for my chlorine, and that is bromate. Hey, cool. Bromate, chlorate. So what's bromite? Well, we said what? Chlorite is 1 less, so what would bromite be? Bromite would be what? BrO2 1 minus. Woohoo! Cool. Hey, this stuff is pretty great. Yeah, you still have to memorize it. Now, chlorate. What is the formula for perchlorate? Ach du lieber. Now we have added what? A prefix. Oh, Mr. Smith. Here we go. Let's talk about how some prefixes help us. Per, that means what? 1 more oxygen than 8. Okay. And there's another prefix, hypo, and hypo means 1 less oxygen than, what do you think? 8. Good. So if we know our 8s and 8s, we can get our pers and hypos. Here we go. Chlorate, hey, chlorate, ClO3 minus perchlorate. What am I doing? Hey, per means 1 more oxygen. So what am I going to do? ClO, not 3, but 4. And my charge stays the same. I like that. That's a piece of cake. Good. You guys do hypochlorite. Pause me and bring me back. Chlorite. Okay. We said chlorate is ClO3 minus, so chlorite, 1 less, would be ClO2 minus. Hypochlorite is 1 less than ClO2 minus, so it would be ClO minus. This is my hypochlorite, chlorite, chlorate. What's perchlorate? ClO4 minus perchlorate, right? Wow, and so this would be my whole family there, isn't it, of my chlorate, chlorites. Now, of course, I could substitute B's, and I would have what? Perbromate, bromate, bromite, hypobromite. I could substitute I's, and I could have periodate, periodate, iodate, iodite, and hypoiodite. Ooh, powerful. Okay, ammonium and dimercury. Well, folks, I'm kind of out of tips. The only thing to do now is memorize. I put these two together because they are cations. Ammonium is NH4 plus, and dimercury is Hg2 2 plus. Di, that makes sense, 2 mercuries, Hg, and has a charge of 2 plus. You just got to memorize that, folks. Next. These are all things you have to memorize it well. And there's one other thing here. Notice these all have 8 in them. And what does 8 mean? 8 really tells us that it is an oxyanion. The 8s and 8s tell us they're oxyanions. And what are oxyanions? These are polyatomics. Which include oxygen. Now, not all polyatomics that include oxygens in this way, but most do. I'll show you a couple exceptions, but the 8 tells us that you've got oxygen in here. Okay, acetate. You just need to memorize this. CH3COO minus. Good. And the reason I write it this way is because it tells me its structure. This is something, this helps me do my Lewis structure when I write it this way. That's what acetate looks like. Now, if you want to do C2H3O2 minus, that's fine. Oxalate, C2O4 2 minus. Oxalate. Oops, oxalate. Good. Chromate. Chromate, CrO4 2 minus. Chromate. Dichromate. Well, if it's di, we know there's 2 CRs, but guess what? It's not 8 oxygens, it's only 7. Dichromate. And then the last one, permanganate. Permanganate is MnO4 minus. Permanganate. Good. All right. There we go. How's that look? All right. You just have to memorize those, folks. Next. Hydroxide and peroxide. Okay, here's a couple more things that can include oxygen. The oxides. Hydroxide is OH minus, and it's extremely important. And peroxide is O2 2 minus. You guys have that? Okay. And let's see. Oops. There's my peroxide. And then we have what? Cyanide. Cyanide is Cn minus. All right, folks. You just have to memorize these. Those are the ones I want you to know. So that would be all for today.